Okay.
Hello? Okay.
Okay.
So a couple weeks back, I sent a patch to set, which is intended to be the first part, well, to add support for, or to make it possible to add support for atomic page flip and to make it easier to add atomic mode set. So, and it's kind of related to the patches that Villa had sent, but I tried to clean up some things and add some property stuff that he needed and so on. So, come on. No, okay, let me try and restart LibreOffice. Otherwise, I'm just going to turn my laptop around and you guys can all look at my screen. Okay. Let's... Oh, God damn it. Okay, this is going to get old. Yeah, the problem is it switches here, but it's not... maybe... there we go. Okay, sorry, back on track. Okay, so first, define what we're talking about here. When we say atomic page flip, we mean page flipping at, well, at least one CRTC, maybe multiple CRTCs, that's up for debate, with one or more plane layers as well, in a single VBlank cycle. So single ioctal to schedule the page flip, and then when all of the FBs for the CRTC and all the plane layers are ready, they get updated at VBlank. And it could also possibly include updating various properties. So if you have some properties to set Z order of planes or color space or alpha blending modes and so on, you might want to be able to update these as well. Atomic mode set, on the other hand, is fairly similar, but it's really to do with mode set on one or more displays. So setting monitor timings, power up sequence and all that. Both of these have the idea of a test flag to let user space say, here's a configuration I want, is this actually possible by the hardware? So why do we need it? The atomic page flip in particular is targeted at compositors like Weston Compositor, which can use hardware overlays for GPU bypass of surfaces. So say you have a 3D game in a window, if the compositor is able to redirect that to an overlay, it actually doesn't need to have a second GPU composition step in the compositor process. So it bypasses a context switch, it bypasses extra work for the GPU, and so on. And this is actually something that's done now in Android. Surface Flinger will do this if the hardware supports it, and it's fairly common in embedded type things. I think WebOS did it, and various other embedded targeted setups, because being able to offload some stuff from the GPU is kind of nice. But that means if you're updating multiple layers, like say you're rendering the parts on the CRTC layer that are now exposed because you're moving a window or something like this, you really want to be able to synchronize updating the overlay position with flipping the CRTC buffer. The other thing is, say you're doing scaling or some other things like this, at some point you'll hit some hardware limit, and the compositor wants to know when it needs to fall back to using the GPU for that, rather than just have a surface disappear or something because you've hit some hardware limit. So atomic mode set, the use case there is really combinations of displays. Like if you have some hardware that can do some certain particular high resolution, if you have one display plugged in but has some lower limits, if you have multiple displays plugged in due to memory bandwidth or things like this. Currently we don't have a way to deal with that cleanly because the mode set on all of the CRTCs is independent. So being able to do combine the mode set and also do a test of a group of settings across multiple CRTCs gives user space a way to actually know this. So the basic, well, one of the things, and this idea actually comes from Villa's patches, is to convert everything into properties. So before, you'd do a page flip ioctl and you'd explicitly pass a FBID, or you'd do a set plane and explicitly pass plane source and destination CRTC coordinates. Now everything is just a property. And the reason for this is, will become a little bit more clear in the future slides, but the short version is it makes all of the state handling of building an updated state and either atomically committing it or rolling it back basically use the same code path. So rather than having to update, CRTC page flip and plane functions and functions all the way around to take a new state object, we can just do it all through set property. That does mean there are some changes in terms of where the error checking happens, but now it's not, the checks to make sure the frame buffer dimensions are valid for the CRTCs you're hooking it at to and things like that. They're not in the ioctl function anymore, but they're still there. So, I haven't been on that slide the whole time, have I? Okay, sorry, that was the slide I was supposed to be on. Okay. So the basic idea is to take, and I've so far just done this for plane and partially for CRTC, although the intention is for atomic mode set that would be finished for connector and the rest of the CRTC properties. So instead of what used to be in struct CRTC and struct plane and so on was a mix of user space settable state and, miscellaneous, a list of supported formats, list heads, different things like that that are not really user modifiable state. So what I did is take everything that is user controllable state and split that out into some different structs. So in this case, struct DRM plane state and struct DRM CRTC state. And then with that, I was able to add some helpers to, if you can see down here at the bottom, check the state or commit the state or set properties. So each individual driver is not having to have lots of code dealing with common properties, let's say. So the way this is intended to work, okay, so this is what I was saying before. Stuff like the CRTC positions, the source positions for a plane are split out into the state structure. The other thing that moves into the state structure is the property values. So there was before in struct DRM plane or struct DRM CRTC a structure that had property values and IDs and so on for keeping track of the user space visible property values. So I moved the actual values into the state structures so that user space seeing the correct value of properties is automatic. If you build up a new state structure for a test stage, or say you want to enable a bunch of overlays and it fails the test phase so it doesn't commit the state changes, user space automatically still sees the old property values. Or if they're committed, it automatically sees the new property values. The intention is that individual drivers could take these state structures and wrap them in their own state structures, which adds whatever driver-specific state. Okay. So, and in the core driver, there's a handful of new functions that a driver supporting this should support. That basically boils down to atomic begin, which allocates some driver overall opaque state structure, check, commit, and end. So check. So the basic sequence, if you look down here, is basically you begin, which allocates some sort of state. You loop through and set a whole bunch of properties, which in turn is under the hood, if necessary, allocating new CRTC or plane or so on state structures and updating them. Then you check the whole new state to see if the hardware likes it or if it's something the hardware can do. If it's good and user space hasn't set a flag saying they only want to test the change, you commit it, which updates the hardware, and then atomic end ends the sequence. And yeah, there's a few miscellaneous changes as part of the patch set. So I add a couple new property types. There's a mode object property. So a property can refer to a CRTC or an FB or some other DRM mode object. There's a dynamic property flag. So the intention is that for settings that the driver can always set without potential failure, you can set this dynamic flag as a hint so that user space knows that it can skip the test step. So say just moving an overlay position, if the overlay's on screen and you just want to move the XY position, the plane's on screen, you just want to move the XY position and your hardware will never fail at that, you can set the dynamic flags on those properties and Weston will know, okay, hey, I can skip the extra octal before I do before I start the GPU rendering. And I also had to add better support for signed property values because some of the values we want to set are signed instead of unsigned numbers. And well, compared to the current state of the patch, I'd actually removed update plane, disable plane, CRTC page flip, because for a driver that's doing everything based on properties, those are no longer needed. Although that changes a lot of drivers, so I probably should add them back in so we can have a transition period. And still some discussion about the actual ioctal itself, how things should be laid out in the structure. And I think that's it. So, I don't know. Any questions? I ran through that kind of quickly. Daniel, are you going to look at, at those patches? I think the intention for like the CRTC and the plane state is specifically the user visible state. So hardware state, you might have in a central structure, or you might tack on to the individual CRTC or DRM state structures. Whatever makes sense for the driver, but anyone? Yeah.
So, how do you plan to compute the bandwidth requirements for planes? Do you just simply do the maximum bandwidth a plane could use, or because
It's up to the driver essentially. That's not so. The core check state functions are checking things like FB dimensions and source and CRTC coordinates and the generic stuff that used to be in the ioctl functions. The hardware-specific things, essentially the intention is that in the driver's check state function, the driver can call, the helper check state for all the boring stuff, and then do its own hardware-specific, bandwidth calculations, clock calculations, whatever it needs to, because that's probably going to be hardware, different from driver to driver.
Yeah. Okay, thanks.
Yeah. All right.
Is the whole validation stuff being redone in the atomic commit function, or is the atomic check function doing all the validation?
The intention is the atomic check function should really be doing all of the checking. I mean, the atomic commit can still return an error, but you want to do all the checking in the commit or in the test function, the check function, because otherwise, if user space is just doing a test only step, they won't see that there's a problem with the configuration they want. So.
Hi, Rob.
Hey.
Hello. Is the return value from the test just a Boolean? I mean,
No, it's an int. So there's already a few different values. Like if you give a CRTC or an FB that's too small for the CRTC dimensions, it will return minus E no space, or in other cases it's E inval or things like that. But it's just the error no essentially that ends up back to user space.
Yeah. I guess on the one hand, it'd be nice for clients to get feedback on what specifically was wrong in their test, but on the other hand, it's going to be so hardware specific and hard to enumerate that it'd be hard for a client to deal with that in the general case.
Yeah, I guess mostly it's going to be E and val, but I mean, a few specific things there might be other more appropriate.
Yeah. Okay.
Yeah.
Would it be useful to provide some more detailed error information? More detailed error information in another call, so you could say, well, I just made this call and you said E and val. Can I get a more detailed error information and perhaps a string returned from the kernel so I can present that to the user and say, oh, by the way, this didn't work because of the following reason?
Yeah.
I mean, because right now all you get is, it didn't work, and you put up a question mark and say, please change your configuration and I'll try again. And some way of getting information back to the user, because we could pass that all the way back through the Windows system to the application if you like.
Yeah, I'm not entirely sure about returning a string, because that gets kind of weird if you want to do like localization or translation.
Life is hard. It's better than nothing.
Yeah. I would agree with that.
Right. You could return an error code, a number, and then you could return a string as well.
Yeah.
But right now we get nothing. And
yeah, it would be nice to have something. I think it can anyways be added on as another patch later. I don't think it has to. I mean, they can be taken piece by piece, because I imagine there'll be some.
Every place you're returning E and val now, you would have to set an error message.
Yeah, I mean, we'd have to add some DRM core set error.
And
function.
whether it was per CRTC or per device or whatever it was.
Yeah.
So
But,
something.
Yeah, I don't know. Suggestions welcome about that. I imagine there'll be some bike shedding about that, so I wouldn't want to block just getting the atomic page flip in place on it, but there's room for something.
Presumably, you wouldn't want, like, the client software using it isn't going to pass it all the way up to the user and instead try to fall back to something else gracefully. So yeah, I agree. A string doesn't seem too useful other than maybe for logging purposes. Maybe another way to handle the fallback would be to have some way for the driver to say, well, that config didn't work, but here's a different config that would work instead. Though I imagine that might be hard for the driver to go through the search space to find a configuration that...
For the mode set, you can have probably more back and forth.
Yeah.
For
for flip,
For
you
the
wouldn't
page
wanna
flip, we
pay back.
basically came to the idea of, let's test what we want to do. If it doesn't work, we'll just fall back to the GPU. And in the case of the atomic page flip, we'll probably, one value error that we might return is eBusy. Because we have, at least in our hardware, there's cases where, like, if you disable a plane on one CRTC and the VBlank on that CRTC hasn't passed yet, we can't yet hook it up to another CRTC. So, I mean, in that case, the idea was, okay, let's use eBusy as a hint to user space that, hey, you can't do this now, but try next frame.
Sure.
But, yeah.
Okay.
All right, anyways, I'll be here all day. So, feel free to ask questions, and yeah.
Okay, thank you very much, Rob, for this talk.